Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now today I'll be speaking on relative velocity. Now so far we were interested in finding out velocity of only one object, and we used these three equations of motion in finding that velocity, right? Now if we have two objects moving relative to one another, and if we are interested in knowing that how fast one object is moving with respect to another object, then in that case we use the concept of relative velocity. Now, relative velocity actually is the velocity of one object with respect to another object. And the formula for relative velocity is simply velocity of A with respect to B is written as velocity of A minus velocity of B. Now another way of saying this is that velocity of A seen by B will be equal to velocity of A minus velocity of B. Now here B is an observer and he observes the velocity of A. Now similarly velocity of B with respect to A can be written as velocity of B minus velocity of A. Now here it can be said that it is the velocity of B seen by A, and that will be equal to velocity of B minus velocity of A. Now here A is an observer and he sees the velocity of B. Now this is how we mathematically formulate relative velocity. Then let's talk about physics, how we physically see it. Now suppose we have a person A and he is driving his car, let me say with a velocity of 11 meters per second, and we have another person, and he is moving with a velocity of 5 meters per second, and we have a third person simply standing on the ground. We have a third person and he is simply standing on the ground. Now for observer C, the velocity of person A is simply 11 meters per second. Now for person C, the velocity for an person B will be simply 5 meters per second. Now if I ask you that what will be the velocity of person A seen by B, quite astonishingly it will be not equal to 11 meters per second. Now to calculate the velocity of A seen by B, we'll use this formula. Now velocity of A seen by B will be equal to simply velocity of A minus velocity of B, that will be equal to 11 minus 5, that will be equal to 6 meters per second. Now what does this mean? This simply means that for B, the person A is not moving with a velocity of 11 meters per second, but he will see the person A moving with a velocity of 6 meters per second, right? And he'll see him moving in the forward direction with 6 meters per second. Now what if I ask you that what will be the velocity of B seen by A? Now that will be simply equal to velocity of B minus velocity of A. The velocity of B is 5 meters per second and velocity of A is 6 meters per second, and it is equal to 11 meters per second, and he will see the speed of simply minus 6 meters per second. Now what does this mean? This simply means that for A, the velocity of B will be 6 and in the opposite direction. That means B will be appearing moving in this direction. Now this is what happens. This is really what happens when we see outside from our car if the second car is being slow. Now if you're driving the car too fast and there is another car outside and he's driving relatively very slowly, what will you see? You will see that he's moving backwards. Now this is what this signifies. We have seen now what it physically means. Now I'll show you some numerical techniques that can be used in relative velocity so that our calculations become very simple and our calculations, or I can say a problem becomes very much simpler. Now, to understand the techniques, let me say that I have a person A, and he's driving his vehicle with a speed of 10 meter per second, and I have another person B, and he's driving his vehicle with a speed of 6 meter per second, and let me say the distance between A and B is simply 40 meters, right? Now, since A is moving faster than B, there will be a point, or I can say there will be a time when both A and B will meet each other, right? They have a distance of 40 meters right now. Now, after some time, there will be this 40 meters will become shortened, and point A will finally meet point B, right? So when we have questions like this, we use some techniques, or I can say we use some shortcuts for finding the time taken or other parameters in the numericals. Now, what I will do is that we will calculate first the velocity of A seen by B, and that will be equal to simply 10 minus 6, that will be equal to 4 meter per second. Now, what does this mean? This simply means that from the observer B, or I can say from the point of view of B, the velocity of A will be equal to 4 meter per second. It will not be equal to 10 meter per second, right? Now, the technique is, in order to calculate the time when A will finally meet B, what you do is that you simply put B at rest, right? And what you do is that don't give A velocity of 10 meter per second, but give it a velocity of 4 meter per second, right? Now here, what has happened is that you have given B rest, and you have given A the velocity of 4 meter per second. Now, if he is moving with a velocity of 4 meter per second, then what will be the time taken by an person A in traveling 40 meters? Now, that will be simply speed is equal to distance by time, and time will be equal to simply distance by speed. The distance is 40 meters and speed is simply 4 meters, so it will take him simply, the time taken by the person will be simply 10 seconds. So after 10 seconds, A will finally meet B. Now, how we have calculated this? We have simply calculated this by using a technique, and that technique is that after calculating the relative velocity, what we do is that we simply put the observer at rest, and we give the relative velocity to the person whose relative velocity we have calculated, right? And then we calculate the time. Now, this is what is done in numericals. So if you have understood this, let's draw a numerical, let's solve a numerical rather, and see how can we solve this numerical, right? Now, what does this numerical say? Now, the numerical says that if a man's speed with and against water current is 15 meter per hour and 5 meter per hour respectively, then find the man's speed in still water and speed of the river, right? Now, let me suppose that the speed, or I can say the velocity of man in still water will be, let me say, Vm, and let me say the speed of the river is simply Vr. Now, we have two conditions here: the man's speed with the water current and the man's speed against the water current, right? Now, let me take the first condition, and the first condition says that the speed of the man with water current. That means simply, if this is the river, right? If this is the river, the person, let me say that person is A, he's traveling in the direction of the current, or I can say he's traveling in the direction of the river. This is what means if a man speed with the current river, right? So that is simply equal to 15 meter per second, 50 meter per hour. If this is Vm and this is Vr, then simply this means Vm plus Vr is simply 15 meters per hour, right? Then the question says the man's speed against water current is 5 meter per hour, right? So what does this mean? That simply if this is our water current, the person will not be traveling in this direction, but he will be traveling in the opposite direction, right? And simply Vm minus Vr, since it is traveling in the opposite direction, that's why I have used minus sign, right? Indicating that velocity of Vm and velocity of Vr is opposite. Now this will be simply equal to 5 meter per hour, right? Now this is the two equation. Let's solve, let's add these equations. What I will get is I will get twice Vm will be simply equal to 20 meters per hour. That means velocity of Vm will be equal to simply 10 meters per hour. That means in still water, its speed, the person's speed is simply 10 meters per hour, right? Now let us, if I put this in any one of these equations, I'll get the speed of the river. And the speed of the river, if I put in this equation, I'll get simply 10 plus Vr will be equal to 15. That simply means Vr will be equal to 15 minus 10, and that will be equal to 5 meters per hour, right? Now I think this is enough for this video lecture. I'll see you in the next video lecture. Till then, take care and study smart.